I left off in the last video saying that we were going to talk a little bit more about marginal revenue and marginal cost in the next video. And it's a good thing I did because I also forgot to talk about average revenue and its relationship to demand. So in this video we're going to cover total revenue and average revenue, and then we're going to go to marginal revenue, which I'm just going to abbreviate MR, and then marginal cost. And we won't really touch on marginal cost, but we'll just kind of talk about how it relates to marginal revenue. So the first big thing is over here in parentheses, and it says that total revenue is equal to price times quantity if the price, or I abbreviated it with just P, is constant for every unit sold. So this is a market scenario, and I'm going to just draw a line here and say market. And the reason I say that is that we never go to McDonald's and haggle for a hamburger. We know that there is a fixed price for that hamburger, and that's because we now have, that is one form of a market. It also is a market where you argue back and forth, but in the kind of market that we're talking about here, we're talking about a market where there's free information and that price is constant and it's just posted up on a sign somewhere. So that's the kind that we're used to in the United States, and so this should seem pretty familiar, that you just multiply price times quantity and that's your total revenue. If price was not constant, then you would sell, let's say you sold one hamburger for $1, and then your next hamburger you sold for $2, and then your next hamburger you sold for $5. Well, you wouldn't have one constant price to multiply by quantity here. So you sold 3 hamburgers, but your total revenue would then be 1 plus 2, which is 3 plus 5 would be $8. So that's if price is not constant. But we're not used to working in scenarios like that, so I'm just going to go ahead and erase this, and we're going to most of the time be dealing with total revenue, abbreviated as TR, is equal to P times Q, price times quantity. So with that in place, now all I want to say is that average revenue is total revenue divided by quantity. And if we work with this in symbols, we get AR, average revenue, is equal to TR over Q. And now I want to go ahead and use this formula up here that I'm underlining in blue to go ahead and substitute that for total revenue. So this is also equal to price times quantity over quantity. And if we cancel out this Q and this Q, we can see that average revenue is also equal to price in a situation where P is constant. So the big kicker is that if P is constant, average revenue is equal to price, and that should make intuitive sense. That if we're selling everything for the exact same amount, that is going to be our average revenue, or our average revenue per unit is another way of saying it, even though it's a little bit repetitive. Okay, so with that in place, now we're going to go ahead and we're going to draw some revenue curves. And to do that, I think it's easiest just to go ahead and give a demand curve and go from there. And so we'll kind of get all of these different relationships. So let's say that we're talking about the market for hamburgers. And let's say that I have my own little hamburger shop. And so if I want to sell Q and P. And so this is really unrealistic because hamburgers would be a competitive market, but just play along with this imagine that there's only one hamburger stand in all of your city. So there's only one place that sells hamburgers. And so if I only want to sell, actually let me flip this around. We're going to go ahead and we'll do P first and then we'll do Q. So if I charge $15 a hamburger, I will not sell a single one, because no one in my town wants to buy a $15 hamburger. If I go ahead and charge $10 a hamburger, I'll go ahead and sell one. If I charge $5 a burger, well, actually no, you know what, let's do 9. If I charge $9 a burger, I'll sell 2. If I charge $8 a burger, I will sell 3. And then if I charge $5 a burger, I will sell 5. So let's say that that's as far as I want to draw out my demand. Let's go one more. If I charge $1 a hamburger, let's say that I then sell 15. So now we have all of the ingredients that we would ever need for a demand curve. And so we're going to go ahead and draw a demand curve now. So we have price up here on the y-axis and quantity down here on the x-axis. And we're just going to start at the top. So at a price of 15, we sell none. And then we're going to hop all the way down here to 10 before we make our first sale. So 10 and 1. And these axes are going to be very roughly done, but that'll be all right. So we have 10 and 1, 9 and 2, $9. We sell, at a price of $9, we sell 2 burgers. At a price of $8, we sell 3. And so we'll just put another dot here. At a price of, this was 8, this would be 7, this would be 6, this would be 5, we sell 5. So this is 1, 2, 3, 4, 5. And then at a price of $1, this was $5, $4, $3, $2, $1. We sell, this was 5. We're just going to put 15 all the way over here. And so now I'm going to pretend that this is kind of curvy just because of the numbers that I made up. And here we have our demand curve. So this is, we could just label this demand for burgers. Okay, so we have a demand curve drawn, and now the connection I want to show you is that demand is equal to average revenue. So this is also called demand, and I'm going to explain that to you. So if we start out and we sell 1 burger for $10, we're looking at this box right here in green, then we made $10. We charged $10 for 1 burger, so we made in revenue $10. In other words, our total revenue, our TR, was equal to our price, which was $10, times our quantity, which was 1, which is $10. And graphically, that is this box right here, this rectangle that I'm shading in green. Now, average revenue is equal to total revenue divided by quantity, or it's also equal to price. And so in this box, our price was $10, and we can see that if we go over to 1 unit of quantity and up to $10, that puts us right on the demand line. Another way of seeing it is that if we work this out as average revenue is total revenue divided by quantity, then we can see that average revenue is equal to 10, which was total revenue right here, divided by 1, which is also equal to 10. And that again gives us this point right here, which is already on the demand curve. So in a market where price is constant, demand is equal to average revenue. And that's a connection that I missed when I went through this class for the first time. I never really had it explained the way that I just explained it here. And I wish that I had, because it's something that to me is very common sense, and it also makes your life a whole lot easier when you go through this later. So we'll do one more example just to kind of build your intuition a little bit more. Let's look at this box in blue here, where we have the option of selling 3 burgers at a price of $8. So in blue, and I'm just going to go ahead and erase all of the calculations that I just did in green because I'm going to run out of space otherwise. So we'll just erase those, and now we'll go back to blue. We can see if we sell 3 burgers at a price of $8, we get total revenue is equal to price, $8, times quantity, $3, which is $24. And then our average revenue is going to be our total revenue, $24, divided by our quantity, divided by 3, which is equal to 8. And so the big thing here is just to see that average revenue is also equal to your price. And again, that should make sense because you're charging the same price to everyone. So that's going to be your revenue per unit, your average revenue. So total revenue would be represented by this green box right here. Or not green, excuse me, this blue box right here. And then average revenue will be this point on the demand curve, or one way of representing average revenue would be by this point on the demand curve, which is also the average revenue curve. So if people ever start talking about the demand curve and they ask what's average revenue at a quantity of 3, all you need to do is go up to the demand curve and figure out what y value demand takes on at a quantity of 3. So we can see without doing any calculations that for a quantity of 5, that average revenue then would be $5. And we could also just see that right over here in this box that I'm boxing in red right now. Alright, so with that done, now I want to talk about the marginals. And the easiest way to think of for marginal revenue or marginal cost to make sense for me is if I talk about a piece of paper, we have on the margin, and I'm just going to draw a piece of paper, or pretend to draw a piece of paper here in red. When we talk about the margins of a page, we're talking about the side right here, the last little bit of the page. So marginal revenue, and I'm just going to write this out because I think it is hard enough to follow anyways without just having to listen to a voice. Marginal revenue is the change in total revenue associated with a 1 unit increase in quantity. Sorry, my little pen tool is kind of messing up here. With a 1 unit increase in quantity. And another way of thinking of it that makes more sense to me is just calling it incremental revenue. And there's also a calculus explanation to it that I'm not going to give you here because I think it just gets more confusing. But if you like math, you should seek out the calculus explanation of marginal revenue. And it's just the derivative, the partial derivative of total revenue with respect to quantity. But I won't say any more about that now because I don't think that that makes sense to most people. So what we're going to do here is I'm going to go ahead and I'm going to erase this demand curve over here. And we're just going to continue this chart because I think the chart is what makes the most sense when explaining marginals. So we're going to really quickly calculate total revenue because that definition that I gave depended a lot on total revenue. And then we're going to go from there. So if I sell 0 burgers, my total revenue is going to be 0. If I sell 1 burger, my total revenue is going to be 1 times 10. And let's just write this out once so that you see it. 2 burgers at a price of $9 is $18 of revenue. Here we'd make $24 in revenue, just 3 times 8. Here we'd make $25 in revenue. And here we'd make $15 in revenue, just 1 times 5, or 1 times 15. So now we need to talk about marginal revenue. And marginal revenue is the change in total revenue associated with a 1 unit increase in quantity. So at the very start, we're going from 0 hamburgers sold to 1 hamburger sold. So we can see then, we can't calculate marginal revenue for no units because there's not an additional unit sold. So for the first hamburger sold, we go from making $0 in total revenue to $10 in total revenue. So our change in total revenue is $10. And I'm going to show you the kind of the formula that I used to calculate this. In this example, I just did 10 minus 0, and that was it because I knew that we were only doing a 1 unit increase in quantity. But in general, marginal revenue, which I'm going to abbreviate MR, is equal to the change in total revenue, TR, over the change in Q. And so I'm going to rewrite that one other way. And so this is also the total revenue, the new total revenue minus the old total revenue, TR sub N minus TR sub O. So the new total revenue minus the old total revenue over the new quantity minus the old quantity. So putting that into practice for this first one, we had the new total revenue was, and I'll do this in green because I calculated this in green. So the new total revenue was 10, minus the old total revenue was 0, minus 0, divided by the new quantity was 1, minus the old quantity, which was 0. So, and 10 minus 0 is 10, 1 minus 0 is 1, 10 over 1 is 10. So I didn't use the formula in my head to do this. I just said we're going up 1 unit, we went up $10 in total revenue. Marginal revenue must be 10. But there are times when thinking about it with this formula does come in handy, and we'll see some of those later on. So in the next step, we go from 1 unit in quantity to 2 units of quantity. So that's a 1 unit increase. And our total revenue goes from 10 to 18. So we have a marginal revenue of the second unit of the second hamburger sold of $8. And I'm going to just go ahead and erase this, and we can work through the formula. And I'm not going to do this for the rest of them, but for the first two I think it makes sense. We could do our new total revenue was 18 minus our old total revenue, which was 10. And those are coming from right here. That was the new one, and this was the old one. Over the new quantity, we are selling 2 hamburgers, minus the old quantity where we were just selling 1. And that is 18 minus 10 is 8. Over 2 minus 1 is 1. So I knew that we had a marginal revenue of 8. Another way of doing it is that I just saw that we were going up by only 1 unit of quantity, so I just subtracted 18, or I subtracted 10 from 18, excuse me. Okay, so the next one, you should be getting the hang of it at this point, or I don't need an equal sign there. If we decide to sell 3 hamburgers for $8, our total revenue then will be 24, and our marginal revenue will be 24 minus 18, which is $6. And another way of reading this, which is probably the most important way, is that if I'm the owner of this burger stand, and if I decide to sell 3 burgers at $8 rather than 2 burgers at $9, I'm going to make $6 additional dollars. And that's the most important interpretation in my mind, because that's the one that business owners actually have to think about when they decide how much they're going to charge and consequently how many they're going to sell. Alright, so now this last one, we want the marginal revenue of 5 burgers, of selling 5 burgers, but I'm going to do 2 different things here. Imagine that I wanted to calculate the marginal revenue per unit. And this may get a little confusing, but I'm going to try and do my best to keep it separate. Marginal revenue per unit. We only gained 1 additional dollar when we went from selling 3 burgers to selling 5 burgers. So we gained 1 more dollar in total revenue, but now we're selling 2 more burgers. So what I'm trying to show you here is that what we are really doing here is we're getting an extra $0.50 per burger from 3 burgers to 5 burgers. And I'm going to work this out more. I don't expect that that makes sense right now. So the first thing is that this jump here from 3 to 5, we are selling 2 more burgers here. And here we are only getting 1 more dollar in sales, 1 more dollar of total revenue. So the marginal revenue per unit, which is really what we've been calculating all the way here, and these really should be, I should have said per unit originally, but this is marginal revenue per unit, this is marginal revenue per unit. Everything that we've been talking about has been marginal revenue per unit. And I've never really seen any other kind of marginal revenue calculated because it doesn't really make sense otherwise. So the marginal revenue per unit here you can kind of see would be a half. And the other way, and this is where the formula makes the most sense to me, is that we take the new total revenue, 25, minus the old total revenue, 24, coming here and here, over the new quantity, which was 5, minus the old quantity, which was 3, and this gives you 1 over 2. So from 3 burgers to 5 burgers, we are making on average $0.50 extra profit per burger, because we're making $0.50 on that 4th burger and $0.50 on that 5th burger. So our marginal revenue per unit here, or our marginal revenue, as even I tend to call it, is 50 cents, or half a dollar. Okay, and now let's find out what our marginal revenue per unit is from 5 burgers to 15 burgers. And we're going to find out that it is negative. So I don't have too much room down there, so I'm just going to go ahead and erase this again. Hold on, there we go. And we'll do this in kind of a bright blue. So we now have our new total revenue is only $15 minus our old total revenue, which was $25. So we're now making less over 15 minus 5, our old quantity. So we are now going to see that we have 15 minus 25 is negative 10, over 15 minus 5 is 10, and we see that we are losing on average $1 per burger, negative 1. I'm just going to clean that up a little, negative 1. And we see that we are from selling $5 burgers for $5 to 15 burgers for $1 a piece. We see that we are on average losing, or I shouldn't say average because I've been talking about average revenue here. On the margin, we are losing $1 per burger from 5 burgers to 15 burgers, because we go down $10 in total revenue here, and we are selling 10 more burgers here. So we are losing $1 per burger that we sell over this quantity range. So with that, I hope that marginal revenue, average revenue, and total revenue makes sense. And then marginal cost is the same process as marginal revenue, only we are doing total cost. So it's, I'll just go down here to the definition really quickly. Marginal cost is the change in total cost associated with a 1 unit increase in quantity. And it's also called incremental cost. So that's really all I need to say about marginal cost. You calculate it exactly the same way as you calculate marginal revenue given total revenue. And with those, I think that we are ready to go on to the next video.